Good morning, all.
Good morning, ma'am.
Yes, screen is visible.
Yes, ma'am.
Fine. So we will continue with the yesterday's part. Fine. So yesterday we have seen ask others to join fast. See, yesterday we have started with the simple execution of the VHDL codes using the Xilinx tool. So I have shown you how to write a code for a simple AND gate, then full adder using data flow, half adder using data flow, half adder using behavioral modeling styles. So today I will show you how to write a code for half adder using structural modeling style. Also, I will show you the simulation, how to perform the simulation in this Xilinx tool. Okay. So before moving further, let's see, revise how what is there in the structural modeling style so that we can write a code accordingly. Okay, so here we will first see how to implement a half adder using a one XOR gate and one AND gate, right? So yesterday we have seen the internal design of the half adder where it has a one XOR gate whose two inputs are A and B, and there will be one AND gate whose two inputs are A and B, right? So this output of the XOR gate is your sum, and the output of your AND gate is your carry, right? So before going for your structural modeling style, we must know the logic diagram or which are the different modules involved in our design. Okay. So this is the internal of your block diagram. Fine. So suppose this is your X1 module, which is the XOR gate, and this is your A1 module, which is the AND gate. Okay. So these two models we have to write, and based on that we have to we have to interconnect them. Fine. So this XOR gate, suppose how this XOR gate is having the input X, its output second input is Y, and its output is Z. Okay. Similarly, for this AND gate, let's say it's one of the input is, I'm denoting it by P, second input by Q, and the output as R. So X, Y are input and Z is the output of XOR gate, and P and Q are the input and R is the output of AND gate. Fine. And what is this A, B, sum and carry? These are the inputs and outputs of our top level module, which is a half adder that we are going to design with the help of its low level modules, that is the XOR gate and the AND gate. So in this structural modeling style, what we do, we first design XOR gate, we design AND gate individually, we verify their functionality individually, and then we just make their interconnections. Okay. So according to this, first I need to create a XOR gate, then I need to create an AND gate. So let's say that it is already there, it is already designed, and you can use those pre-compiled design in your code also. So here, let's see, we will create a new project of the structural modeling style. So you will get a complete idea what is exactly there in the structural modeling style. Okay. So here, HA struct. This is the name I am giving to my project. Fine. Next, here we need to select a hardware properties, but right now we are not going to dump it in any hardware. So you can keep it as it is. Just make sure here preferred language should be VHDL. Next, finish. So here we have created a project. On this left hand side window, you can find the name of the project, HA struct. Below that there is the device properties. Okay. So whatever the by default selected, it you can find it here. Then right click on this and we create a new source. Fine. So now we will go in steps. So initially I am going to design an XOR gate. So here VHDL module we are going to write. Now here I am giving a name XOR, sorry, XOR gate. This is the name I am giving. XOR you cannot give because it is a one of the reserved word. Next, then this XOR is having the input X comma Y, okay, and Z is its output. So here you can select an out. Now I'm going to define its functionality using a data flow because I'm going to write in just the Boolean expression. See, it's not compulsory that you have to change this architecture name. If you keep a name as a behavioral and you are writing a data flow code, then also it is fine. Okay, it will work properly because it is simply a user defined name. If you give your name and you write a functionality of structural, then also it is okay. But why it is always a good practice to use a proper conventions for your code so that it will be easily readable by other programmers. So that's why these names must be specific. So here I'm giving a data flow. Next, finish. So this you can see the window appeared where you have to write the functionality of a XOR gate whose output is Z. So Z, I will write equal to, it is XORing between X and Y. So X XOR Y. So this is simply a Boolean expression I am writing for that XOR gate. Okay. So here we have completed this XOR gate working. We will synthesize it in this below left side second window. You can find here check syntax, also view RTL schematic. So just click on synthesize XST. If you double click on that synthesize directly, the whatever the process is inside it, all will be simulated simultaneously. Okay, X comma Y. One more semicolon was comma was there. That's why there was an syntax error. Now let's see synthesize XST. You can find in console process synthesize XST completed successfully. There can be some warnings you may get at a times. So here we can say that XOR gate is converted into its RTL schematic. You can click on view RTL schematic and you can find here XOR gate. So if you double click on it, again you can see there will be a AND gate and the OR gate. I will minimize it. So it is XORing, it is simplified in terms of its input variables like x bar y plus xy bar. Okay, x bar y plus xy bar. So this you can find here two AND gate with one of its input. There is a bubble. So what we are doing, it is the active low inputs you can accept to these inputs. Fine. And there is one OR gate which combines the outputs of the two AND gate. So this is the design created for our XOR gate. So this is the part of the synthesis only. So we have checked that whether our design, whether our code is converted into its hardware or not. Also, we have to check whether it is simulating properly or not. Okay. So for that simulation, what we can do here, click on simulation. See, on left hand side window here, wherever design is given, implementation by default, there will be the implementation whenever you are writing, you are synthesizing it. So there is another option is there simulation. So you have to just tick on this button, okay, and click on this your file XOR gate. See on the left hand side window, and on the below processes window, you will find a simulate behavioral model. Okay, so just double click on that simulate behavioral model. So now you can find this new window appeared. Okay. So initially here there are no any signals given. So you are finding the yellow lines at the in this waveform. Fine. This black screen you are seeing all the yellow lines because it is undefined. You can mention, you can find here X signal, Y signal and Z signal is given. And here U is given. So it is the undefined values are there. So what we have to do, we have to check now whether whatever the code I have written, it is properly giving us the output of the XOR gate or not for different values of X and Y. So we have to change this, check these values of X and Y, and we have to observe the Z. Okay, so here you can see in this object window, X is given. See, I have highlighted it. You can find it in a blue color. So here X value is having U, Y is U, and Z is also U. But Z is your output. So you don't have to give the value for that Z. You have to assign the value to only X and Y, and based on those values, Z will be changed. Okay, so right now what I am giving to this X, I am right clicking on it, and there is a one option, force constant. Okay, so what I am giving, I am giving a new value to that X. So click on force constant. Here force to a value, I am giving a 0 here. Okay, click on apply. Okay, similarly to this Y, I am forcing again force constant. I am giving a value 1, apply. Okay, fine. So once you give this value, here there is option run all. Okay, also run for the time specified on the toolbar. So click on run all. Now you can check here. You are getting the output as a 1. So 0, this first is the 0. Here you can check the value 0, 1, and output is 1. You can now, what you can do, you can change this value. Just a minute. Now I'm going to change the value again here to 0. Force constant, 0, apply. Okay. And again I am going to run it. So now for 000, you are finding it here a 000. Wait. Okay, fine. Now you can minimize it. If both the values, now you can see this yellow cursor. 0, Y is also 0, so your Z is also 0 you are getting. Now I am changing the value of Y as 1. Okay, force constant, Y as 1. Apply. Okay. Now again you can run it. Now see, you can find this yellow cursor, 0 is there. Now Y I have changed to 1. Now your output is also changed to 1. Similarly, if there is a value of X and Y, both are 1. So I am changing the value of X and Y to both are 1. Fine. Now I am changing it. Now see, you can find the next value appeared here on your black window. 1, 1. Now your output Z. Okay, now output Z changed to 0. So in this way, you can verify or you can check the simulation of your code. So for given inputs, for a given different combinations of input, whether you are getting a desired output or not. If it is okay, then you can say our design code is okay, and that can be used in the further design. Okay, so this is the one thing that we have completed our XOR gate, which is one of the module of your half adder. Fine. Now what is our task? Now we have to check for the AND gate. Okay, so again what I'm doing in this left side processes window here, I'm right clicking on it, new source and VHDL module. Now I'm going to write a AND gate. Okay, so here I have written a AND gate. Next, here inputs of the AND gate are P, comma Q, and output is R. Right. So here I'm changing it to out. Similarly, the architecture name I'm changing to data flow. Click on next, finish. So now here the AND gate code will appear. Here I can write the functionality of R equal to, what is it? It is simply P and Q. It is simply P and Q. So in the same way, now on this left hand side, you can check AND gate is there, also XOR gate is there. Now out of that, which one should be uh, executed? So you can click on it, click on implementation. Here you can see by default your XOR gate is a top level model. Here three squares you can find. So what you have to do now, click on right click on AND gate and click on set as top model. Okay, so click on set as top model. Yes. So now your AND gate is a top module. Why? Because in right now we have to implement only AND gate. So again, you can click on a synthesize XST and we can check the functionality of this AND gate individually. Fine, tick is there. So you can view the RTL schematic of the AND gate square box. And inside this square box, only one AND gate is given, whose one input is P, other input is Q, and the output is R. Okay. So this is again AND gate. So for this AND gate also, you can check its simulate behavioral model. Here again, you can find, now you can check the values for values to 1 or 1. I'm initially making both P and Q as a 1. Apply, okay, and you can run it. Okay. What next you have to do? So you can minimize it so that it can be viewed properly. See 1 1 and you can find the output is 1. Now what I'm doing, I'm changing this constant to 0. So if for AND gate it is 0 and second one is the 1, then what will be the value? Then 0 1 output is 0. Fine. So in this way you can verify. Now we can say that if both the inputs are 1, we are getting the output 1. For all the other values, your output of the AND gate is 0. So in this way we can say that my AND gate is also working fine. Okay. So till this point, what we have done, we have written two codes. One for XOR gate, we have checked its functionality. We have written AND gate, we have checked its functionality. So now what is we are interested in designing a half adder using this previously designed units. Okay. So for that, I'm now writing a new source. Again, right click on that, click on implementation, right click on that, click on a new source. Again, it is a VHDL module. Then give the name. Now I'm giving a name HA. Okay, HA half adder. Click on next. Now for this half adder, which are our inputs? For this half adder, we have the inputs, actual inputs A and B, and outputs are sum and carry. Okay. So these actual pins you have to mention for this. So this is my A, comma B are the input and sum, comma carry are the output. Out. And I'm giving the name for this as a structural, just for understanding, structural modeling. Next, finish. So now you can see the entity created, entity HA, ABR in and sum and carry are the out. Now here we have to mention the code for the structural modeling. So what we are interested in this code, this is a top level code which are showing the interconnection. So for that, this file must know which components we are using. Okay. So we are using the component of XOR gate and component of the AND gate. So what is the first step in this structural code you have to write? You need to declare the components. Okay. You need to declare those design units which you are going to use in your code. So which we are using the XOR gate. So we have a XOR gate code with us here. Okay. So XOR gate is already there. So what you have to copy? You are going to copy this entity as it is. Okay. I'm simply copying this entity as it is and I'm putting it my new that top level code. Okay. Where before after architecture statement and the before beginning statement. Why? Because this is the declaration part. and we are declaring a component here in our code. So what I'm doing, simply I have just copy pasted the entity as it is. Okay, but it is not entity. What we have to do, we have to mention it as a component. So component, 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 XOR gate is port, it everything will remain as it is. Okay, and at last you have to write end component. So what is there? We are simply copying the entity of previously designed unit into our code, and we are using it as a component. Okay. In the same way, we have an AND gate. You will copy its entity as it is. Okay. And you will paste after this component. Okay. Because two components we are using now. So I have pasted it here. So you can change, instead of entity again, our name should be component. And get is end component. This is the syntax for component declaration. So none. Fine. So in the declaration part, I have copied or I have written these two components. One is XOR gate and one is the AND gate. Fine. Now in what you have to do, in the begin you have to show the interconnection of the XOR gate and AND gate with your actual design. Okay. So in this code, if you see, uh, your XOR gate, if your component is XOR gate, that is the X1, I am giving a label to it. Okay, X1 then colon, then you have to use the entity name. I have given the name for my entity as a XORGAT gate, right? And in bracket, XOR gate, then you have to write a port map statement. Okay, we have seen this previously in the modeling style, port map, and in bracket you have to map the port, actually means XOR or ports of the XOR gate you have to map with the ports of the half adder. Okay, so in this case, what is your X input of XOR gate? Our X input of XOR gate is nothing but A, right? So your X will be mapped with A, right? X will be mapped with A. What about Y? Your Y input of XOR gate is nothing but a B port of our actual design. So Y will be equal to B. And what about Z? What about Z? Z is nothing but a sum. So what is this? This is the component instantiation statement, we can call it as. Okay. So you have to write the same thing here. Suppose the label I am giving as X1, then name of the entity I am giving a XOR gate, then port map. Okay, port map statement you have to write port map, and here you can mention your X will be mapped to A. Sorry, X will be mapped to A. Then your Y will be mapped to B, and your Z will be mapped to some output. So this is the one of the way you can write a component instantiation statement also. Or what you can do, I will show you the another way of writing also. This also, this I have commented it. You can simply write A, then B. See, here you have to keep the sequence same. A, B, sum. Why? For this XOR gate, it's one of the input will be A, second input will be B, and output will be sum. In the same way, second component is suppose my AND gate. So A1, name of the entity of AND gate is AND Then same port map. Here, which are the port maps are there for this AND gate? Which are the port maps? That for this P is mapped to A again. P is mapped to A, Q is mapped to B, and R is mapped to, where the R is mapped? R is mapped to carry, right? Here R is mapped to carry. So same thing you can write here in your code using the another way, A comma B comma carry. Okay, semicolon. So fine. So this is your code for your the structural modeling style. You can save it. Now you can find here on the left hand side window, as we have used the both the components, so you need to change it to top module. So set as a top module. Yes. Now you can see under this HA, which is a top level module, you can find the two modules. One is the XOR gate and second one is the AND gate. Now you can synthesize it. Fine, green tick is there. So your process of the synthesize is completed successfully. Now what we have to do, we can view its RTL schematic. See, this is your HA. We have seen. Now, what is the HA? In HA, there is a C. We know one is the AND gate and one is the XOR gate. So you can find there the boxes. If you again double click on that, in this AND gate, there is only one AND gate, and XOR gate, it has actually a two AND gates and one OR gate. So this is actually a complete get level design of your half adder using a structural modeling style we have written. Same you can also simulate. Click on this simulation. Click on the this file and simulate behavioral model. Now I will show you. See, simulation will be same irrespective of your modeling style. Now A and B, left right click, force constant, A is 0, apply, okay. Then B, force constant, B also 0, apply, okay. So A and B both are 0 I have given. So click on run all. See, you can check here. All are the 0, right? All are 0. You can minimize it. Then for 0 0 or sum is 0, carry is also 0. Now I am giving a next combination is the B I am changing to 1. B I am changing to 1. Apply, okay. Now run. You can check here, it is changed. Now you can change here. Initially both were 0, so sum was 0, carry was also 0. For 0 1 you are getting the sum 1, also carry 0. Now next combination, I am forcing A as a 1, apply, and B as a 0. B as a 0, apply, okay. Now you can run one more time. Now for 1 0 you are getting 1 and 0, same. Now the last combination is you have to force the B also 1. B also 1. So in this case, what will be the output? Again run. See, for A and B 1 1, your sum is 0 and carry will be 1. So with the help of cursor, you can find this value here in the value column also. So this is the simulation. You can change the value and you can check how what will be the desired output for that particular design. Okay, so here we have seen the complete flow of writing a VHDL code using a Xilinx, how to simulate it. Only the one part remaining, that is actually the part of your practical, and that is the implementation. We have simulated it in the computer itself. We have not used any hardware till now. So the next part is actually a implementation of this on the hardware. So that we will cover in the practical part. So here I have shown you all the three ways of the modeling style with which we can write a code. Generally, we go for either data flow or the behavioral, but you can find the structuralist is quite again easy, because here you have to simply concentrate on the smaller modules, and then you have to just make their interconnections. Okay. If you have any doubt at any point, you can ask. Yes. Anyone, any doubt? You can practice it, because I don't know now. I think for this year, academic year, there will be the practical examinations, um, means actual practical examination if we starts with the offline only. But still, you must aware how is the design flow. Instead of going with the complete theory part, how we are going to implement it practically, which are the tools we are using, how is the design flow, that you must know. Okay, that's why I have taken it in the initial few sessions only, that how to write it and the simulate your VHDL code. Initially, you will find it quite difficult or confusing, time consuming also. It takes a time and there are lots of processes or lots of steps you need to do. But once you practice it, it is quite easy one. Okay. So we will start with the next part. It is 9:35. We will take an attendance and then remaining part we will start in the next lecture. So in the next lecture, we will see the remaining topics, language elements of the VHDL, like the operators, then different sequential statements, concurrent statements. Right now, it's okay that you don't understand all the statements, but at least you must understand the design flow of this front end design. Okay, front end that is using a PLDs, how we are using the PLDs for prototyping purpose to fix our design or to complete to verify our design. Okay, we'll take in attendance and then from the next lecture we will start with the remaining language construct